All right, example 4, it doesn't have any calculus in it at all. It just asks us to evaluate the log base 2 of 45. So think back to your algebra days, back before the magical update to the TI calculator allowed you to change the base from either a base e, the natural log, or base 10, the common log. If you had to evaluate the log base 2 of 45, you'd have to use a change of base formula. So just to make sure that we understand what log base 2 of 45 is, remember it's an exponent. Log base 2 of 45 is an exponent that you have to raise to 2 in order to get 45. And what is that number? Well, that number, with the change of base formula, let's see if this will just write on here for me. Excellent. Is equal to the natural log of 45 divided by the natural log of 2. The base is always on the bottom. That is the change of base formula. And in calculus, that's how we define the log of any other base other than e. E is the standard, and then we base everything else off of that definition. And it goes like this. If a is a positive real number that is not 1, and x is a positive real number, then the logarithmic function to the base a is denoted by log base a of x and is defined by, wait for it, log base a of x is equal to the natural log of x divided by the natural log of a. Once again, that's just essentially the change of base formula. And sometimes what we do is we just take that natural log of a that's in the bottom and we bring it outside to the front of this as a fraction. So it's like a coefficient that's being multiplied times the natural log of x. And that's basically what I'm going to do right here on this next exercise, in which we wanted to use that definition to find the derivative of log base a times x. Okay, we did something similar with exponentials, right? We found the derivative of e to the x, and then later when we learned how to use the chain rule, we found the derivative of y is equal to a, some other base other than e, to some power, okay? That's what we're going to do here. So in order to do that, though, I have to use that little definition. I'm going to change this base. I'm going to rewrite this like this. Y is equal to the natural log of x divided by the natural log of a. And just so that it's clear, the natural log of a is just a number. It is not a variable. I'm going to rewrite it. I'm going to rewrite it as 1 over the natural log of a. It's just a constant that I'm multiplying times the natural log of x. Now I want to take the derivative of that function. So y prime is equal to, so this number 1 over the natural log of a as a constant is just going to carry through. It's like the number 2 or something like that. So 2 times, and then I said like it was the number 2. I didn't say it was the number 2. Jeez. 1 over the natural log of a times, and now the derivative of the natural log of x, as we've come to expect, is 1 over x. And there's a variety of things that you could do in order to rewrite this in a nice way. Maybe it's 1 over the natural log of a times x, or something equivalent as just one fraction. All right, which brings us then to the derivatives of the natural log, not the natural log, the log base a times x. All right, so it's got the same exact setup as the definition. Let a be a positive real number that is not 1, and let u be a differentiable function of x. So once again, we're going to get a chain rule version of this. So the derivative with respect to x of the natural log of a of x is equal to 1. I keep saying the natural log. No, the log base a of x is equal to 1 over the natural log of a. That one is natural. Times x. And then here's a graph of a sample of 1. And then here is the graph of its derivative. Okay. And then the, let's say the chain rule version of this, the derivative with respect to x of, let's see if I get it right this time, log base a of u, where u is a function of x, is equal to 1 over natural log of a times u, all of that multiplied times the derivative of that interior function. And just as we saw before, you could, of course, just make that a u prime, which you put up top.